Hello everyone. Today we'll have our numerical part 1 of chapter 1. So in this presentation we'll be discussing about few problems which is based on Coulomb's law. The type of problems we'll be discussing are to find the net force using Coulomb's law. So few problems based on Coulomb's law, that is to find the net force. Let us start with a very simple one, that is exercise 1.2 of your course book. Read the question. The electrostatic force on a small sphere of charge 0.4 microcoulomb due to another small sphere of charge minus 0.8 microcoulomb in air is 0.2 Newton. A. What is the distance between the two spheres? And B. What is the force on the second sphere due to the first? So here we have to use the Coulomb's law formula. F is equal to 1 by 4 pi epsilon naught q1 q2 by r square. And your force is given in the question. 2 point charges, 2 spheres of charges q1 and q2 are given. And we know the value of 1 by 4 pi epsilon naught, that is 9 into 10 raised to minus 9. And you just need to find out r, value distance is asked, that is r is asked. So first of all you rewrite the formula for r square. So r square is equal to, for 1 by 4 pi epsilon naught we can substitute k. So k into magnitude of q1 into q2 by f. Okay. Substitute k is equal to 9 into 10 raised to 9 and q1 is given 0.4 microcoulomb, so 10 raised to minus 6. q2 is minus 0.8 microcoulomb, so only magnitude we are considering 0.8 into 10 raised to minus 6. Divided by force is 0.2 Newton, that also substituted. Do this calculation. Okay, you will get r square is equal to 144 into 10 raised to minus 4 meter square, that is r square it is. Okay, now we can find out r by taking square root of this, that will be 12 into 10 raised to minus 2 meter or 0.12 meter. So this is the answer for that A part. This is the distance. The B part is what is the force of second sphere on the first. Both forces will be equal and opposite, so same value will get 0.2 Newton only. Force will be same. Okay, that is the solution of that problem. Now let us move on to the second question, that is example 1.6 of your course book. Consider three charges q1, q2, q3 each equal to q. So magnitude of all the three charges q is given at the vertices of an equilateral triangle of side L. What is the force on charge capital Q with the same sign as small q placed at the centroid of the triangle as shown in figure? So this is a book diagram given in your book. Actually these direction and all you only have to mark for exam. Only this question and one triangle with the three charges will be given. Other diagram, this marking of this direction, everything you only have to do. This will not be given in the question. That you will understand when we discuss another problem from the board paper. Okay, this is the one which is given in the book. So let us understand it properly. Three charges q1, q2 and q3. So q1 is here kept here at A, q2 at B, q3 at C. Each charge has a value of small q. So q1 is q, q2 is also q and q3 is also q. So that is the three charges on the vertices of equilateral triangle. What is equilateral triangle? Each angle is 60, 60, 60. That is equilateral triangle. And you are asked to find out the force on charge q, which is kept at centroid. This is the centroid of the equilateral triangle. A charge q is kept here. Both are having same sign. So nature of the force will be repulsive. Same sign. So repulsive. Either both are positive or both are negative. Like that it is. So repulsive nature of the force. So accordingly you have to mark the direction of each forces. So let us consider the force on charge q, that is at centroid, due to first q1, due to A, this force. What will be the direction? So force on charge q due to q1 will be repulsive, so away from the charges. So this is direction of F1, away from this, repulsive. Similarly, force on charge q due to q2, that also will be away from q. This is F2. Along the same line, and away, repulsive. Similarly, force on Q due to Q3, that will be the direction away from that, away, same line but away from Q, that is repulsive. So all these three forces are repulsive nature, F1 in this direction, F2 in this direction and F3 in this direction. So how do we find the net force acting on Q due to this F1, F2 and F3? You have to apply vector addition, right? That is total net force will be, that is force due to multiple charges. Large number of more charges are there, you have to apply the superposition principle. Net force on charge Q will be equal to F1 plus F2 plus F3. And we cannot add it directly like our addition. We have to use vector addition. So vector addition of F1 plus F2 plus F3 will give you the net force acting on this Q due to these three charges. Okay, that is a basic thing you need to understand. First of all, you have to mark the direction of F1, F2 and F3. Then you have to apply vector addition. So here F1 is along minus y direction, downward direction. Let it be there. Okay, F1 in the downward direction. Now consider F2 and F3. The resultant of F2 and F3 will be by using parallelogram law of vector addition along the diagonal of this parallelogram. So this is the resultant of F2 and F3. Let it be represented by F23. So this arrow represents resultant of F2 and F3. So this is in which direction? Positive y direction. So you have to add this F23 and F1. Again vector addition, F23 plus F1 will give you the final force. They are acting in the opposite direction and we have to find out the magnitude. So to find the magnitude, you can directly apply Coulomb's law, 1 by 4 pi epsilon naught Q1 Q2 by R square. Like that you can find out F1, F2 and F3 separately. Then resultant of F2 and F3 you have to calculate using parallelogram law. And finally you have to find out the net force acting on Q by adding F1 and F23, resultant of these two. That's the procedure. So let us understand it. Once again the diagram is drawn here, same diagram only, angle also marked here. Okay, so F1 in the downward direction, F2 in this direction, F3 in this direction. So by the property of this equilateral triangle, this angle is 60 degree. So this angle will be 120 degree. Angle between F2 and F3 will be 120 degree. So total it will be 180. So this is B, C and each charge, everything is represented. So resultant force at the centroid of the triangle is due to charges Q1, Q2 and Q3. Each of magnitude Q is the vector sum of three forces F1 plus F2 plus F3. This is by the superposition principle. Net force is equal to F1 plus F2 plus F3. Now from the diagram, direction of F1 on charge Q is due to Q2 is given. F2 shows the force on Q due to Q2 and F3. See this notation. F1 is the force on Q due to Q1. F2 is the force on Q due to Q2 and F3 shows the force on Q due to Q3. That is shown here. All forces are of repulsive nature. And the direction. F1 act in minus y direction. Okay, that one all I have explained already. F1 direction is minus y. Now consider F2 and F3. Okay, F2 and F3. So we can find out the resultant of these two forces by using parallelogram law of vector addition. And it is denoted by F23 and the resultant is acting in plus y direction. That also I have shown, plus y direction. F23 in this direction, plus y, upward direction. Now we can find out the resultant at Q will be, then final force, final resultant of force at Q will be vector addition of F1 and F2, 3. Okay. Now consider an equilateral triangle. There are certain properties of equilateral triangle. We need to find out the magnitude of each force first. So let us consider an equilateral triangle. This is a simple diagram I have drawn to represent equilateral triangle of side length L. So each side is L. So this is L by 2 and this is also L by 2. Draw a perpendicular from A to BC. That's AD is the perpendicular. We can find out this distance AD. AD is represented by H. So height of this perpendicular H square by Pythagoras theorem. We can write H square is equal to L square. That is this hypotenuse L square minus base L by 2 whole square. That is L square by 4. So H square is equal to 3L square by 4. Therefore, this distance height h is equal to square root of this, that is root 3 by 3, square root of 3l square by 4, that is root 3 by 2l. This is this height, okay. Now by property of our equilateral triangle, you might have studied in your lower class maths, the distance AO and distance BO, that is from vertex to centroid. From vertex to distance of vertex to centroid of an equilateral triangle is given by 2 by 3 of the perpendicular. Okay, 2 by 3 times AD. That is the property. AO equal to BO equal to CO equal to 2 by 3 of this distance AD. And AD distance we have already found out, root 3 L by 2. So we can find out the distance AO, BO and CO. Why we need this distance? Because we are finding the force between these points A to O, B to O and C to O. So we need to substitute for R, distance R, in the formula of Coulomb's law. So for that purpose we have found this distance, that is 2 by 3 of AD. AD we have found using Pythagoras theorem. So we'll get distance AO is equal to 2 by 3 of root 3L by 2, which is nothing but rewriting this one, that is simplifying this one, 2 by 3 into root 3 L by 2. We'll get root 3 L by 3. Just write down and see the cancelling of this and we'll get this like this, root 3 L by 3, because 2 cancels and root 3 L by 3. Again rewriting it, multiplying numerator and denominator with root 3, we'll get L by root 3. Okay, simplification of root 3 by 3 is 1 by root 3. So we are getting the distance AO, BO and CO as L by root 3. So this is the distance we are getting. So this is the part we have to find out. This is the distance we have to substitute in the Coulomb's law equation, okay, for finding the magnitude of each forces. Hope it is clear. This is based on the property of equilateral triangle, okay, and this calculation is simple calculation. Root 3 by 3 is nothing but 1 by root 3, okay, so 1 by root 3 of L. Now we will find out the magnitude of each force using Coulomb's law. So F1, 1 by 4 pi epsilon naught, centroid charge in the centroid is capital Q and charge on vertex A is Q divided by distance is L square into 3. Okay. Similarly, find out F2. Here also we can write 1 by 4 pi epsilon naught Q into Q by L square into 3. Why this L square by 3? How it came? Because the distance is L by root 3. So F1 is equal to 1 by 4 pi epsilon naught Q by L by root 3 square. That 3 is come in the numerator and root L by 3 the square. Okay, 1 by root 3 L is the distance, that square. So L square by 3, that 3 in the numerator. So here also. Similarly F3 also. All the magnitudes are same, right? Because same charges Q and distance, each distance AO, BO, CO, all the distance are also same. So we are getting same formula for F1, F2 and F3, which is equal to 1 by 4 pi epsilon naught Q into 3 divided by L square. Same values will get. Now we have to find out the resultant of F2 and F3. Okay, for that we have to use the parallelogram law. First of all, we have calculated F1, F2, F3 separately. F1 let it be there, that is acting in the downward direction. Now resultant of F2, 3 we have to find out F2 and F3 using parallelogram law. This is the parallelogram law of vector addition. Square root of F2 square, magnitude of F2 square plus magnitude of F3 square plus 2 into magnitude of F2 into magnitude of F3 into cos theta. Theta is the angle between F2 and F3. And in the diagram we have seen that angle is 120 degree. And we have already found the magnitudes of F1, F2 and F3. From that we have observed that each magnitude is same formula we were getting. So we can substitute, simply for simplification we can substitute magnitude of F2 equal to magnitude of F3 equal to F. Let us substitute like this. Then substitute in the formula F2 3 is equal to square root of F2 F. F3 also F. So F square plus F square plus 2 into F2 into F3, that is 2 into F into F2 F square into cos theta. Theta is 120, cos 120. That 120 angle I have shown in the diagram. Okay, angle between F2 and F3. So resultant of those two we are finding using parallelogram law. So substitute for cos 120, which is minus 1 by 2. This value you need to remember. In most of the cases it will be 120. In that case you can substitute that. Simplify this 2f square plus 2f square into minus 1 by 2. 2 cancel, so it will be minus f square. So 2f square minus f square. This part I hope you have understood. 2f square into minus 1 by 2. So that 2 and this 2 cancels and there is a negative sign. So this will become minus f square. So that is here. And this is f1 square plus f2 square here. You should not add these 3f square together, okay? There is a term cos 120 along with this one. That calculation you have to complete, then add these two. So you will get 2f square minus f square is equal to square root of f square, which is f. That means we are getting the resultant of f2 and f3 as f itself. What is f? f2 or f3? Same. That formula itself we are getting. f23 is f only. That is 1 by 4 pi epsilon naught q into q by L square into 3. That only we are getting for F23. Now we will find out the resultant force. What is the resultant net resultant force on q is given by F23 minus F1. Okay, what is F23? This formula. F1 also same formula. And finally what we are getting is 0. So the final answer is 0 because the same forces are acting in the opposite direction. F23 also we are getting same magnitude as F1. So F23 minus F1 which are acting in the opposite direction, that is by this negative sign. Vector addition means here we have to subtract because of the opposite direction. Since magnitude of these two are same, we are getting the final answer as 0. Okay, this is how we need to solve these type of questions. Hope it is clear. Okay. Now we'll consider a question from board paper 2018. 3-point charges Q, minus 4Q and plus 2Q are placed at the vertices of an equilateral triangle ABC of side L as shown in figure. Obtain the expression for the magnitude of the resultant electric force acting on charge Q, small q. Okay. So this is the diagram which is given. I said no, only this much will be given in the question. All other marking, direction, everything you only have to do. Now just understand this question. So Q is here, minus 4Q is here and 2Q is here. You are asked to find out the resultant force acting on this Q. So each force direction you have to mark first. So these two, force on Q will be due to force on minus 4Q and due to force on plus 2Q. So net force acting on Q will be due to this force and due to this force. And what will be the direction between these two? It is attractive in nature. Between these two it is repulsive in nature. So due to these two it will be towards this charge and between these two it is away from this charge. Like that you have to mark the direction and we will find out the resultant using vector addition. So this is the diagram. So I said between these two, that is force acting on A due to charge at B is attractive. So it will be from A to B, attractive in nature, A to B. Whereas force acting on A due to charge at C, both are same charge or repulsive in nature. So it will be away from A. So away from A. So this is denoted by FAC, force on A due to C. So FAC in this direction, FAB in this direction. So here also this angle is 60. This is equilateral triangle 60, 60, 60 and this angle will be 120 degree. Okay, total will be 180. So this angle will be 120 degree. So the resultant of FAC and FAB, that will be the final answer. This FR represents the resultant of FAC and FAB. Using parallelogram law of vector addition, we can find out the resultant force. Okay. So it is given, the explanation is given here. FAB is at A to B and FAC is away from A. And the resultant force on A due to charges on A and C is given by vector sum of FAB and FAC. We'll find out the magnitude first. Okay, FAB and FAC magnitude we'll find out first. Then only we can apply the parallelogram law. So FAB is equal to 1 by 4 pi epsilon naught. What are the charges? Q and 4Q. Only magnitude we need to consider. This minus sign we don't have to consider. That we'll be considering in the vector addition. So 4Q into Q. So 4Q square by distance is L square. And it is acting along AB. Force on charge Q due to the charge 2Q, second one. This is Q and 4Q. So 4Q square by L square. Between Q and 2Q, 1 by 4 pi epsilon naught, 2Q square by L square along CA. This is FAC. So FAB and FAC we have found. The resultant of these two will give you the final force. And the relation between FAB and FAC, you can note down that FAB is 2 times FAC. That is here 4Q square, here 2Q square. So to substitute in the parallelogram law of vector addition formula, we write this relation. So FAB is equal to 2 times FAC. Now we can substitute, let FAC is equal to F, then FAB can be 2F. This is just to substitute in that equation, in that formula. The resultant force FAC plus FAB, vector addition of FAC and FAB using parallelogram law of vector addition is FR is equal to square root of FAC square plus magnitude only, FAB square plus 2 FAC into FAB into cos of angle between FAC and FAB, which is 120. Now just substitute this FAC equal to F and FAB is equal to 2F. We'll get this is F and this is 2F square. So F square plus 2F the whole square. So 4F square plus 2 into F and FAB is 2F into cos 120 is minus half. Now simplify this. First of all, only add these two. So F square plus 4F square is equal to 5F square plus 2F into 2F into minus half. So 2 cancels. So remaining we will get 2F minus 2F square. So 5F square minus 2F square, that is square root of 3F square, that is F into square root of 3, that is square root of F square is F, so F root 3. What is F? F is nothing but FAC. This is a substitution we have given. FAC is F, so root 3 into FAC, and FAC, magnitude of FAC we have already found using formula. Substitute that. So we get root 3 into Q square by 2 pi epsilon naught L square, because FAC is 1 by 4 pi epsilon naught 4 Q square by L square. That 4 and this is cancelled. So we'll get 2 Q square. So 2 and 4 cancelled. You will get Q square by 2 pi epsilon naught into L square. Okay. So just substituting FAC. FAC is 2Q 1 by 4 pi epsilon naught 2Q square by L square. The 2 and 4 cancel, so 2 comes here. So we get the final result as square root of 3 into Q square by 2 pi epsilon naught L square. So this is the resultant force. Direction of, so we can write it as 1 by 4 pi epsilon naught. In another way we can write it as 1 by 4 pi epsilon naught 2 root 3 Q square by L square. By cancelling, we can write like this, and without cancelling, in the general format of Coulomb's law, we can write it as 1 by 4 pi epsilon naught 2 root 3 Q square by L square. So this is the final result of our problem, which is acting along minus x direction, because final force was acting in the minus x direction. That also we can write down in the answer. So, okay. So this is how this type of problems are solved. So marking the direction and using the vector addition method and using the Coulomb's law. So this is the way you have to solve all these type of problems. Okay. One more question. The same question paper, it's OR part. 4 point charges Q, 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 Q. Okay, capital Q, small q, capital Q and small q are placed at the corners of a square of side A as shown in figure. Find the resultant electric force on a charge Q. Okay, one more part is there, that is from the next chapter. Okay, resultant electric force. You have to find out the resultant electric force on a charge Q. So which charge Q is not specified. Either you can select this Q or you can select this Q. The answer will be same. If you select this charge also, answer will be same. So here also, first of all, you have to consider the directions. So let us consider this charge q. Okay, we are considering this charge q. Then mark all the directions of forces due to these three. So what will be the resultant force acting on this q due to this q plus due to this q plus due to this q. For that, let us mark the vector notations. Okay, this is how you have to draw the diagram. So this is the charge q we have considered to find out the resultant force. So it will be having three forces, okay, due to this charge kept at A, due to charge kept at B, due to charge kept at D. Okay, let us denote the force on Q, that is force on Q which is kept at C due to charge at A as FA, which will be acting in this direction, direct along the line of these two charges, and since they are repulsive in nature away from point C. This is FA direction. Similarly, due to B, away from that, FB direction, repulsive, due to D, FD in this direction. All the three forces are moving away, that is repulsive in nature, 1, 2 and 3. Okay, is that clear? Now FD direction is along X direction, FB direction is along minus Y direction, and for FA this is the direction. Okay, let it be there. Now we have to find out the resultant of FB and FD because they are making an angle. There is an angle between FB and FD which is 120 here also. You see, sorry 90 degree. So FB and FD, angle between FB and FD is 90 degree. So you can note down that is this angle FB and FD is 90 degree. So using that we can find out the resultant of FB and FD. So first of all let us find out all the magnitude of forces using Coulomb's law. FA represents force on Q due to Q, and FB represents force on Q due to this Q, and FD like this. Then FA is equal to 1 by 4 pi epsilon naught. Now what about this distance? Distance also you have to find out. See, this distance is A. Only this is given. So this diagonal distance will be by using Pythagoras theorem, square root of A square plus A square. That is square root of 2A square. That is square root of 2 into A. This is outside the square root. Okay, root 2A is this distance using Pythagoras theorem. Okay, square root of A square plus A square. So root 2A. So that you have to substitute. So FA is equal to 1 by 4 pi epsilon naught Q into Q. This force we are finding, FA, force on this Q due to this Q, capital Q only. So Q into Q, Q square by distance is root 2A, or A root 2 whole square. That is 1 by 4 pi epsilon naught Q square by square root 2 A square is equal to 2. So 2A square along AC. FB. Second one is FB. So what will be FB force between this small q and capital Q. So 1 by 4 pi epsilon naught Q into Q divided by distance is A, small A square along BC. Okay, along BC. Now FD, force on this C due to D. Okay, force on C due to charge kept at D. That is not by FD. That will be again charges Q and Q. So 1 by 4 pi epsilon naught Q into Q divided by A square along DC. Okay. So three forces we have noted down. FA, FB and FC using Coulomb's law. And charges we have multiplied in the numerator. Distance we have considered in the denominator. We are getting three formulas. Okay. Let it be here. Now what we have to do next step. FB and FD. These are the two component vectors. We have to find out the resultant of FB and FD, that is FBD, and that along with adding that force and FA along the same direction will get the resultant force. So resultant force FR is equal to FBD plus FA. What is FBD? Resultant of FB and FD. That and FA along the same direction. So vector addition of these two will give you the resultant. For that we have to find out FBD. Since magnitude of FB and FD is same, we can write FB equal to FD equal to F. From the formula you can note down FB and FD magnitudes are same. Now we have to find out the resultant using parallelogram law of vector addition. So FBD is equal to square root of magnitude of FB square plus magnitude of FD square plus 2 into magnitude of FB into magnitude of FD into cos theta. Theta is 90. You can see in the diagram angle between FB and FD is 90. It is cos 90 0. So this term 2f square into 0. This term will not be there. You have left with only f square plus f square. Entire term will not go to 0. Okay, only this term will goes to 0 because cos theta is multiplied with this term only. So FBD is equal to square root of 2f. FBD is equal to square root of 2f square, that is f root 2. Now substitute for f, we get, so what is f? We have substituted FBD is equal, FB equal to FD equal to f. Then substitute that value into root 2. Just multiply with the root 2, we'll get f into root 2, that is 1 by 4 pi epsilon naught q into q by s square into root 2. That will be the resultant force which is acting along AC. Okay. So this is the final force acting along AC. Well, sorry, not final force, FBD we are getting. Now we have to find out the net force acting on Q. So this is FBD. Okay. Now net force acting on Q is given by vector sum of FA and FBD. So F resultant is equal to FBD plus FA. Okay. FBD plus FA. So what is FBD? This one. This is FBD, and what is FA? This one, this formula. So root 2 QQ by 4 pi epsilon naught a square plus 1 by 4 pi epsilon naught q square by 2a square. Simplify this. Here we have, here this term is q by a square, and here also q square by a square, and 1 by 4 pi epsilon is common. Like that you simplify this one. So we'll get 1 by 4 pi epsilon naught q by a square is taken as common. So inside the bracket q by 2 will be there from the one term and root 2q from the other term. So this is the final resultant force acting on charge q due to all the three charges kept at A, B and D. And the resultant force is acting along AC. Okay, AC. For the charge q at the point AC, this is the case when we are considering the charge q at point C. Suppose if we are considering the charge q at point A, the force will have the same magnitude. This is the magnitude will be same, but it will be directed just opposite CA. This will be the only difference. Okay. Since we have considered charge at C, this the direction will be along AC. So this is how we need to solve this question. Okay. Another question is example 1.7. Okay. Example 1.7. So this also you can try solving. Okay. Just try solving this question. It is given in the book. Here also you have to find out, mark all the directions. Consider charges Q, Q and minus Q. So Q here, one Q here and minus Q here at the vertices of an equilateral triangle as shown in figure. What is the force on each charge? So on each charge you have to find out. First of all, find out the force on this charge, then here, then separately. So first one here, direction you mark the force. So these two, on this charge A, the force will be due to this charge as well as due to this charge. Due to this charge, force on A due to B, what will be the direction? Both are positive, so repulsive. So force on 1 due to 2, F12 will be away from it, repulsive. Force on 1 due to 3, F13, it is attractive, so towards this, F13 will be in this direction. The resultant of F12 and F13 will give you F1 using parallelogram law of vector addition. Similarly, find out the force at point B. Direction of force on charge 2 due to 1 will be away from it, repulsive. Force on 2 due to 3 will be attractive, so towards it, F23. Resultant of these two will give you F2. Now, the force on charge 3. Force on charge 3 is due to 1 as well as 3. So, F31 will be towards it, it is attractive. F32 also will be towards this since it is attractive. So, resultant of these three will be F3. Like that you have to mark the angles. I have said these directions you only have to mark, it will not be. So, like that it is. So force acting on, now we have to find out the direction, magnitude of forces. We can write F1 is equal to 1 by 4 pi epsilon naught q square by r square. F1 and F2 will be same value will get, same forces, no, only opposite side. So resultant F3 will be is equal to square root of f square plus 2f square into cos 120 1 by 2. So F root 3. Now F1, the force on F, first charge F1 is same as F along BC, force on F2 is same as F along AC, and F3 will be root 3 times F along angle bisecting BCA. So this is how the forces we will get for 3 cases. Now next question is example 1.6, question number 5, example 1.6. Try solving this also. 4 charges are given at the corners of square of ABCD 10 cm. What is the force on charge 1 microcoulomb placed at the center of the square? So you have to draw the diagram first. You draw the diagram and you can note down that the directions of force at the center due to 4 charges, they are equal and opposite. So try solving this by yourself, equal and opposite. Just draw this diagram and solve this, okay? I have given, but still you try by yourself. Here you will get the net resultant force will be 0 because all are cancelling each other. So that is the answer for that one. Final answer will be 0. Question number 7 is exercise 1.12. Okay, this also try. It's directly applying the formula. Okay, direct to application formula. Okay, a few homeworks also I have given. Exercise 1.12, remaining exercise still 1.7 I have given because only those questions which comes under the Coulomb's law force it is given. So try to understand all these problems. Few problems are direct application of formula, and these type of marking direction and everything, that is the important type of problem. So we have solved few board questions also. So now you have an idea what are the type of questions asked from Coulomb's law. Okay, hope it is clear. Try to understand it proper way.